we are doing the Manhattan tourist problem in the form of a grid. So in order to find the value of S0j, for which 0 is less than or equal to j and j is less than or equal to m, it is not very difficult to find this value. In this case, tourists do not have a choice of its own. So he or she has to move in the east direction. And in this case, we can find the value of 0j, and when the tourist will move in the east direction, so the value of 0j will be the sum of all the values of the grid's edges. And in the first, we will find the value of j city blocks. So similarly, we can also find the value of Si0 in the same manner. So in this case also, the tourists do not have a choice and it has to move in the south direction. And again, we can find the value of Si0 by calculating the sum of the edges grids values, and we will come up with the value of Si0. If the tourist has to reach at the point 1, 1, then the tourist has only two choices to reach at this point. The one is either by traveling south from 0, 1 or east from 1, 0. So we can calculate the weight of either of these paths as number 1 is S01, this one 0, 1, and we will calculate the weight of the edges between 0, 1 and 1, 1. And similarly, the second option will be, we can calculate the consider 1, 0 here, 1, 0, and we will calculate the weight of all the edges between 1, 0 and 1, 1. So since the goal is to find the longest path, and the longest path in this case is 1, 1, so we will choose the larger of all these quantities, because we know we have to calculate the largest path, that is Sij, and as well as we have to find the largest grid value also, that is Snm. So in this case we will consider the maximum Nm value, and in this case it is 1 plus 3, that is equal to 4, as compared to 3 plus 0, that is 3. So we will consider this value as the value of 1 by 1. And since there are no other ways to get the grid position 1, 1, we have to find the longest path, that is 1, 0, 0 to 1, 1. We can see here in this grid also that if we consider the tourist is at the source position, that is 0, 0, and it has to move to the 1, 1 position. This is 1, 1 position, and first the tourist has to move either to 0, 1 position or 1, 0 position. So this 3 is the 0, 1 position, and this 1 is the 1, 0 position. From this position, the tourist can move either in this direction to approach this 1, 1 position, or in the east direction to reach the 1, 1 position. So if the tourist will move from this 0, 1 position to 1, 1 position, we can see here the value of this one is 3 and the value of this is 0. So the total value will be 3. But if the tourist will move from 1, 0 position and reach the 1, 1 position, then we can see here the value of this edge is 1 and this value is 3. So if we plus 1 and 3, we come up with the value of 4. So we can see here the longest path and the longest weight will be if the tourist will move from 1, 0 to 1, 1 position in this direction. So we can also conclude, and we can see here that it is denoted by a bold arrow, and this is not denoted by the bold arrow. So it means that the tourist choice should be from source to this direction and then to this direction to gain the maximum weight values. And we know that this weight value means that the tourist will see the most of the sightseeing by using this path. So we have seen in this module that the tourist has a very little choice. Either he or she can move in the south direction or in the east direction, and we can easily calculate the weights value by assuming their path. So it is very easy, and this is the beauty of this dynamic programming algorithm, that we do not have to calculate the value every time. So the pre-calculated values, they are used to calculate the further values. So in this case we have seen that the tourist has only two choices to reach at the 1 point, and we will select the point that has the higher value of n and m.